In the previous video, we answered the question, how does OSPF get away if there's lots and lots of routers all connected to the same network segment? How do we avoid doing full adjacencies with OSPF? The answer was a DR and a BDR. In this lab, I'd like to walk you through a scenario where we have 4 routers on a common broadcast Ethernet network, and then we'll go through an exercise to identify, determine, and verify which devices are DRs and which are DR others. So here is our game plan. We've got 4 routers 1, 2, 3, and 4. And they are all connected to a common Ethernet segment. They're using gig 0/0 for each of them. And I thought a great number for this network would be 10.12.34.0 because it has routers 1, 2, 3, and 4 in it. And then we're using the router number as the interface IP address as well. So that'll be .1, .2, .3, and .4. Also, each of these routers has a loopback interface of 1111, 2222, etc. for 3 and 4 as well. Now, the OSPF adjacencies are all set up. However, because it is a Ethernet network segment and it's an OSPF network type of broadcast, one of these devices is going to be the designated router. Another one of these routers is going to be the backup designated router, and the other 2 are going to be druthers. And if they're all powered up at the same time, the one that will be the DR is going to be the one that has the highest OSPF priority on this gig 00 interface. If they're all at the default of 1, which they are, heads up, then the tiebreaker is going to be the highest router ID. And if R4 has loopback of 4444, basically he would have the highest router ID. He would win as the designated router for this network segment. And R3, having the next highest, would be the BDR. And so if that happens, and we'll verify that in the lab, if that's what happened, we should have full adjacencies between router 3 and router 4, between router 2 and router 4, router 1 and router 4, and also between router 2 and router 3, and router 1 and router 3, because they are the DR and BDR. And the 2 commands that can help us identify and document this network are show IP OSPF interface brief. That will tell us on the router itself for this interface, is it a DR, is it a BDR, is it a DR other? And to see our neighbor relationships, show IP OSPF neighbor. So here's our topology, and here is what I would like us to document by looking at the topology in this lab. And by using just 2 commands on each router, show IP OSPF interface or show IP OSPF interface brief, your choice, as well as the show IP OSPF neighbors, we can identify on R1, R2, and R3 and R4 regarding their gig 00 interface on each of those devices, which is connected to this network. We can identify the local interface state. Is it a DR? Is it a BDR? Is it a DR other? And these neighbor states that it has. So what is the relationship between R1 and R2, and R1 and R3, and R1 and R4? So what I would like us to do is router by router, go to the interface, which we'll do together now, and I strongly encourage you to do this in the lab as well to get that hands-on practice. We'll go router by router, run those 2 commands, and then fill in this table to get a very clear picture of the interface states and the neighbor relationships. All right, so we'll start here on R1 with a show IP OSPF interface brief. And locally, this device on its gig 00 interface, its state is druth. Well, that's a shortcut because there's not enough room for it. For druther, we could also do a show IP OSPF interface, and we can put in gig 0/0, press enter, and that'll give us the full story. So there it says state druther for that gig 00 interface. So we can go back to our table. Let's do that. And here in our table, the local interface state for gig 00 is druther. As in, I'd rather not be a DR. I'd rather not be a BDR. All right, so this local state is druther, and then we'll do the show IP OSPF neighbors to find out its relationship, R1's relationship with R2, R3, and R4. So back on R1, we'll do a show IP OSPF neighbor and press enter. And this says for router 2, our state is 2A druther. For router 3, it's full/BDR, meaning we have a full adjacency, and that device is a BDR. And with R4, we have a full adjacency, and that device is a DR. So we'll add that to the table. So R1 regarding R2, it was a 2A druther. And with R3, it was a full and BDR. And for R4 is full, and R4 is the DR. So what I would like you to do is I'd like you to repeat this process for router 2, router 3, router 4, identify the local interface state of gig 00, and then its relationships, R2's relationship with R1, R3 and R4, R3's relationship with R1, R2 and R4, and so forth. So pause me right now, go ahead and do this lab, and then come back and we'll fill out the table together once you've done the work. So my question is, did you pause me? Did you do the lab? And I know some of you may be on a mobile device or not able to get to the lab right now, but if you have done it right now, fantastic. If not, please schedule time, just a few minutes to get that hands-on practice. Together now, let's go ahead and finish off this table. So let's go back to the CLI. So we'll go to R2 and router 2. We'll do a show IP OSPF interface brief, and we'll do a show IP OSPF neighbor while we're here. Great. So the local interface is a druther for gig 00, and here are the relationships between R2 and R1, which is 2A druther, R2 and R3, which is full, and R3 is a BDR with a full adjacency, and R4 is the DR. So we can add that to our table. So here we have druther for the local state, and its relationship with R1 is 2A druther. It does not have an adjacency with itself. Between R2 and R3, it's full, and BDR, because R3 is a BDR, and R4, we have full and DR. Great, let's repeat the process for R3 and R4. So here in R3, we'll just show IP OSPF interface brief. Fantastic, and a show IP OSPF neighbor. So R3's interface on that network segment is acting as the BDR, the backup designated router. It's got full adjacencies with everybody, including R1 and R2, which are both DR others, and the actual designated router itself. So let's add that to the table. So here on R3, the local interface is a BDR. Its relationship with R1 is full, and R1 is a DR other. Its relationship with R2 is full, and R2 is a DR other. We're on R3, so we don't need to worry about that relationship. And R3's relationship and adjacency with R4 is full, and R4 is that DR. And we've got one more. In fact, we could, based on this information here, without even looking, we could fill this in. We know that R4 is the DR. Everybody says that that's what he is. So R4 is the DR, and the relationship with R1 is full, and R1 hasn't changed. R1 is still a DR other. The same thing with R2. And the designated router is going to have a full relationship with everybody, and R2 is still a DR other. And with R3, we're going to have a full relationship, and R3 is the BDR, and then R4 is ourself, so it's non-applicable for that relationship table right there. So that's it. And one of the benefits of doing this lab, and maybe doing it 2 or 3 times, and predicting based on the interface states what the other relationships are going to be, is that in a production environment, when you're doing show commands and trying to troubleshoot OSPF, by understanding what the output means, for example, what does 2A druther mean? Or what does full druther mean? Or what does full/BDR mean? The practice we do now and the experience we get hands-on now is going to assist us in being much, much better in the heat of battle. So thanks for joining me in this lab, in this video. I had a great time putting this together. Hope you enjoyed it as well. So I'll see you in the very next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.